Hello, I am 3STEM. Last week I talked to you about finding the nth term of a polynomial sequence, and in your homework you had to write the series using sigma notation to show the sum of the first n terms of the finite sequence. Finally, as a result of I being to the nth power and using the formulas of sums, we were able to give answers to sums in polynomial expressions. Now this week, we'll talk to you about how to find those nth terms by using finite differences that lead to polynomial expressions, and the fun continues. So here we're going to utilize how to solve a number of unknowns when we have that same number of unknowns as we have equations. In other words, two equations and two unknowns, or three equations and three unknowns, and on and on and on. It only gets more fun, and not only that, Ms. Schoen here has created a video that shows how to use a special matrix method that's referred to as the Gauss pivot method to solve it in a really slick way. This is best taught by solving examples in front of you. So here we go. Now, before we actually solve anything, we need to describe this idea. What is a finite difference? Well, first differences of a sequence are found by subtracting consecutive terms. And it always has to happen where the later term has to subtract the term in front of it. So a sub 2 subtracts a sub 1, a sub 3 subtracts a sub 2 in order to find the differences. And you know that in when you were talking about a linear model where you were looking at arithmetic sequences always had the same common difference, right? And that was always the first differences were the common differences, and that's what made it an arithmetic sequence. But what if the first differences are not the same value? Well, then a possibility that maybe the second differences might be. And so this is how this goes. Take a look at this set of numbers. The first and second differences of the a sub n row that you see here. First of all, let's take a look at what a sub n is. So when n is 1, a sub n is 3. When n is 2, a sub n is 5. And the next term is 8, and the next term is 12, and the next term is 17, and the next term is 23. Well, let's take a look at the first differences. Well, the difference between 3 and 5, when I take 5 and subtract 3, I get 2. When I take 8 and I subtract 5, I get 3. When I take 12 minus 8, I get 4, and 17 minus 12, I get 5, and 23 minus 17, I get 6. Well, in the first differences, we do not have the same number. But let's take a look at second differences. 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1. And 6 minus 5 is 1. And so the second differences are the same number. When this happens, the sequence has a perfect quadratic model, meaning we're going to have n to the second power. And for the first differences, all are the same, is a linear model, and so that's how it is in arithmetic. Now, if we took this argument further and said, well, what if we had to wait until we got to the third differences and those were the same? Well, guess what? Now we're going to be saying n to the third is going to be the first term of, and we're going to go on to n to the 2 and n to the 1 and n to the 0 in order to describe the polynomial that describes the nth term of the sequence. So let's start off with something simple, shall we? Here's example 1. And let's go ahead and take a look at the differences. 5 minus 3 is 2. 8 minus 5, 3. 12 minus 8, 4. 17 minus 12, 5. 23 minus 17 is 6. Now that's first differences. They aren't the same. Let's go for second differences. 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1. 6 minus 5, 1. Wonderful. We are at second differences. That makes this a quadratic expression. And so that means that a sub n now is going to be, and I'm going to use the coefficients big A n squared plus big B n plus c, which is n to the 0 power. So that's what the expression looks like. And now we have to figure out what the coefficients a, b, and c are in order to write a complete version of the nth term a sub n. And here's how it's going to go. It takes, in this case, we have 3 unknowns, and so it's going to take 3 equations. Well, here's some things that we know. That in the first case, when n is equal to 1, that a sub 1 is 3. But that's made up from a times n squared, but n is 1, so it's just a. And n is 1, so that's just b. And then plus c, and that's going to equal this value up here, 3. Because that's what a sub n is when n is 1. So when n is 2, I have 2 squared, which is 4, times A plus 2 times B plus C, and that's going to equal my second term, 5. And n equals 3. That's going to give me 9A plus 3B plus C, and that's going to equal 8. And I'm going to go ahead and label these guys. This is going to be my first equation, this is my second equation, and this is my third equation. And I like to label those things because it gives me something to follow as I'm actually doing the subtractions in order to find the three equations and the results of the three equations and three unknowns. So you see, I'm going to do this. I'm going to say, let's do equation 2 and subtract equation 1. And when I do that, I get 4A plus 2B plus C is equal to 5. There's equation 2. And I'm going to subtract equation 1. So I'm just going to do it term by term. So that's minus A minus B minus C is equal to negative 3. So if I just add straight up and down, I get 3A plus B. C's go away, and 5 minus 3 is 2. So, and I'm going to name this one equation 4. Now I'm going to get another equation, and I'm going to do that by taking equation 3, and I'm going to subtract equation 1. And watch what happens when I do that. I have 9A plus 3B plus C is equal to 8, and I'm going to subtract from it negative A, negative B, negative C is equal to negative 3. And when we add straight up and down, I get 8A plus 2B. C's go away again, and I get 8 minus 3 is 5. And I'm going to call that equation 5. Well, if I take that information now and I subtract 2 times equation 4 from 5, watch what I get. I get 8A plus 2B is equal to 5. And I'm going to subtract twice equation 4. So it's going to be minus 6A minus 2B and negative 4. So when I do that, I get 8A minus 6A is 2A. 2B minus 2B is gone. And 5 minus 4 is 1. So that gives me an A of 1/2. Now, if A is 1/2, then all I have to do is go back to maybe equation 4. And I can say 3 times 1/2 plus B is equal to 2. 3 times 1/2 is 1.5. And if I subtract that from both sides, I get that B is equal to 1/2. Now, if B is equal to 1/2, then I can go straight up to the top and go A plus B plus C is equal to 1/3. Well, that's like saying 1/2 plus 1/2 plus C is 3. And so that's 1/2 plus 1/2 is 1. 1 plus C, subtracted from both sides, C equals 2. So finally, what this is saying then is that A sub n is equal to 1/2 n squared plus 1/2 n plus 2. And that's my expression for my nth term of the sequence. Now, we're not done with that. We have to actually go to now writing the sigma notation. So we're talking about S sub n, and we're going to write that in sigma notation now. So we're going to use that using an index of I. So I is equal to 1, and we're going to n, and we're going to write 1/2 I squared plus 1/2 I plus 2. Now, if we use the properties of summations, then we can actually say it this way now. We're going to copy the sigma notation part and put that down here, and we're going to make another copy, put it right here, and make another copy and put it right here. And we're going to use our properties and some formulas, and it's going to look like this. So I have 1/2 goes in front, and I have I squared going in here, and I'm adding that to 1/2 goes in front of this sigma, and I get an I right here, and now I have plus 2, and I have a 1 inside the sigma. So when we evaluate these sigma notations, we get this now. We get 1/2 times, oops, that's a squared there. And so that turns that into n times n plus 1 times 2n plus 1 over 6. And that's added to 1/2 times n plus 1 over 2. And that is plus 2 times n. And let's clean this up a little bit. So now this is going to be, we have an n as a common phrase in each one, so we can pull out n. And we're noticing too that our common greatest common denominator is turning into 12 because 2 times 6 is 12. So that leaves inside parentheses then n plus 1 times 2n plus 1. And here we're looking for a denominator of 12. We have a denominator of 4, so I have to multiply by 3. And so that's going to be multiplied by 3 on top. And so that gives me a 3 times n plus 1. And then we need a 12 down below here. And so that's going to take multiplying a 12 on top. And so that turns that into plus 24 because the 12 is factored out along with an n. And so there we have it. So that turns this into, let's clean this up a little bit more, n plus 1 times 2n plus 1 becomes 2n squared plus 3n plus 1 plus 3n plus 3 plus 24. And there's the n over 12 outside. Continuing to clean this up, we've got 2n squared plus 3n plus 3n is 6n. 1 plus 3 is 4, and that plus 24 is plus 28, and we have n over 12. Now, we have a factor of 2 common into every term inside the parentheses, so we can pull that out and cancel it with the 12, and that turns that into n over 6, and inside is n squared plus 3n plus 14. That is not factorable, and so here is our summation. Here's another one. Let's try this. Let's take a look at first differences. We're now going to subtract where we take the next term and subtract the previous term. So negative 4 minus negative 2, that's plus 2, that gives me negative 2. So the difference is negative 2. Negative 4 minus negative 4, that's plus 4, that gives me 0. Negative 2 minus negative 4, that's plus 4, so that gives me 2. And the next one, 2 minus negative 2, that's 2 plus 2, that comes 4. And 8 minus 2 is 6, and 16 minus 8 is 8, and 26 minus 16, that's 10. Well, let's take a look at, so that's first differences. And so let's take a look at second differences, shall we? 0 minus 2, that's 2. 2 minus 0 is 2. 4 minus 2, 6 minus 4, 8 minus 6, 10 minus 8 is 2. So we got second differences, the same again. And so look at what we have. This is going to be now a sub n is going to equal big A n squared plus big B n plus c. And so there we have it. We're going to do that again. And so now we're going to just, let's collect up our terms. When n is equal to 1, then I know that A plus B plus C is equal to negative 2. And let's go for n equals 2. Well, that's going to be 4a plus 2b plus c, and that's going to be equal to negative 4. And n equals 3 will yield 9a plus 3b plus c, and that's going to equal also negative 4. Okay, let's go ahead and name these. This is going to be equation 1, this is going to be equation 2, and this is going to be equation 3. And let's go ahead and do some subtracting. So if I do 2 minus 3, 2 minus 1, equation 2 minus equation 1, now I get 4a plus 2b plus c equals negative 4, and that's going to be minus a minus b minus c equals 2. So I can just add straight up and down. I get 3a, I get plus b, c's go away, negative 4 plus 2 is negative 2. And so I'm going to give that one the name equation 4. And we're going to do this again. We're going to take equation 3 and let's subtract equation 2. And that's going to be 9a plus 3b plus c is equal to negative 4. And I've got negative 4a, negative 2b, negative c is equal to positive 4. So when I add straight up and down, I just get 5a plus b. C's go away, and I have negative 4 plus 4 is 0. So that's going to be equation 5. So let's take equation 5 and subtract equation 4. So equation 5 is 5a plus b equals 0, and we're going to subtract 3a minus b and 2. So b's go away. I end up with 5 minus 3 is 2a is equal to 2. And when I divide both sides, I get a equals 1. So a is equal to 1. Well, that's going to be easy enough down here. We'll call that 3 times 1 plus b. That equals negative 2. And so that means that I can subtract 3 from both sides, and that gives me b is equal to negative 5. So if b is equal to negative 5 and a is equal to 1, I could just use equation 1 and say 1 plus negative 5 plus c is equal to negative 2. Well, I can combine 1 and negative 5 and get negative 4, and add 4 to both sides and get c is equal to 2. So you see, I have now that a sub n is equal to n squared plus, minus actually, because it's negative 5n plus 2. Now, as we work this to create our sigma notation, this is what we end up with. That S sub n is equal to sigma with an index of I to n of I squared minus 5i plus 2. And if we use our properties again, we get this. So S sub n is now equal to I squared minus 5 times sum of I plus 2 times sum of 1. So that just turns this now into n times n plus 1 times 2n plus 1 over 6. So that's the first term. Minus 5 times n plus 1 times n. I wrote that backwards, but it still works. And then plus 2 times n. Well, that gives my S sub n a common factor in the numerators of n, and in the denominators I see a greatest common factor of 6. And so we're going to go ahead and just pull out n over 6. And as we do that, now this is what we have. N plus 1 times 2n plus 1 minus 5 times n plus 1. And we need to resolve that denominator, so we need to turn that into times 3. Times 3 is going to make that 15. So that's a 15 in front, not 5. And then plus, we need a denominator of 6 again. So that's going to take multiplying the top by 6. We've already factored out the n, so that leaves behind 12. That turns this into now n over 6 times 2n squared plus 3n plus 1 minus 15n minus 15 and plus 12. So when we continue to combine and clean things, we get n over 6 outside, and inside we have 2n squared. 3n minus 15n is negative 12n, and 1 plus negative 15 is 14, negative 14. Negative 14 plus 12 is negative 2. And it looks like we also have a common factor inside of 2, so that's going to cancel out with the 6 and become n over 3. And inside now we have n squared minus 6n minus 1, which is not factorable, and so our S sub n is complete. And there is the sum of the n finite differences. We're going to take this up to another level in example 3. So take a look at this list of numbers here, and let's go ahead and start looking at the differences. So as we look at the differences, we're going to subtract 3 from 37 and get 34. We're going to subtract 37 from 131 and get 94. We're going to subtract 315 minus 131 and get 184. You're noticing that we're getting 4s at the end. I think that that's going to make the second difference is a little bit easier maybe. If we subtract 619 minus 315, we get 304. 1073 minus 619, 454. 1707 minus 1073, 634. 2,551 minus 1,707, 844. Well, that's first differences, and they're very different. So we should continue on to see if we have more interesting differences to consider. Well, 94 minus 34, that one's an easy one, that's 60. 184 minus 94, that's 90. 304 minus 184, that's 120. 454 minus 304, 150. Starting to look a little bit more orderly here. 634 minus 454, 180. 844 minus 634, 210. All right, so that's our level of second differences, and we're still not the same. So let's just keep going and see if we can get it now. So third differences now. We're going to look at 90 minus 60, that's 30. 120 minus 90, 30. 150 minus 120, 30. 180 minus 150, 30. And 210 minus 180 is 30. So we got third differences are the same. So that means we're talking about a cubic, and that tells us then that a sub n is going to be a n to the third plus b n squared plus c n plus d. And that's going to be the form because it's going to be a cubic, and all the descending exponents will be represented. And so this means then when n is equal to 1, we're going to be looking at a plus b plus c plus d is equal to our first term, which is 3. A sub 1 is 3. Well, let's look at when n is equal to 2. 2 is going to be 2 to the third is 8, a, plus 2 to the 2 is 4, b, plus 2c plus d, and that's going to equal our second number, which is 37. So a sub 2 is 37, and equals 3. Now we're looking at 3 to the third, that's 27a plus 9b plus 3c plus d, and that's going to equal our third term, which is 131. You notice that the numbers are starting to get pretty astronomical because it's only a sub 3 and we're at 131. So now we're looking at n equals 4, and this will be our last one. 4 to the third power is 64, a plus 16b plus 4c plus d is equal to our fourth term, which is 315, because a sub 4 is 315. And as you see, what we're looking at is 4 equations and 4 unknowns. And I'm going to stop right there. I'm not going to do this one for you. But what I am going to do is I'm going to recommend that you take a look at Ms. Schoenherr's video on how to use Gauss's pivot method for solving something like this, like a 4 by 4. So go ahead and watch that. Give this one a try. This is as far as I'm going to go with this one. Maybe what I will do is I'll post at least what it looks like to finish this one off in some fashion. And then just do your homework. And there's going to be at least one tough one in the homework. So go ahead and do that. Now, so here's the homework. We got 10 problems for you. We're back to the series worksheet. So just pick those numbers off and go ahead and give it a try, finding finite differences to solve for your a sub n, and then work it to the end of that. And if you have questions, you know where to find me during study hall. You also know how to email me and arrange a meet, and I'm happy to do that. And otherwise, I'll see you later.